Welcome to the future of IIoT and condition monitoring. These podcasts are a series of interviews with industry leaders about where they've been and where they think they're going. Our hope is that these discussions will encourage the skeptical reliability or maintenance manager to consider testing the water for wireless condition monitoring. Our goal is to build confidence with this new technology within the industry by talking to the technology leaders, those with products and services that have stood the test of time. I am Ed Spence, your host. I'm the founder of the Machine Instrumentation Group, which represents a network of consultants and engineering contractors with expertise in condition monitoring and predictive maintenance. My hope is that these conversations encourage you to take the next step. Today, my guest is Jaclob Loverich, the Chief Product Officer of KCF Technologies. Jacob, thanks for joining me today.
Glad to be here, and thanks for hosting this, Ed. Should be an engaging conversation.
Yeah, I'm pretty excited about it. So, to the audience, in the interest of full disclosure, Jacob and I have known each other for a long time. We've both been in the business. I'd say almost since the beginning of IoT. You guys are one of the first vendors out. It has to be getting close to 15 years ago when I visited you guys in State College to talk about MEMS accelerometers when I worked for Analog Devices and whether MEMS was the right technology or what the technology should look like for condition monitoring. And you guys, I think, as I recall, you guys were one of the first outfits out there with a wireless condition monitoring sensor. It was that device with the energy harvesting mechanism built in.
Yeah, that's right. I mean, it's I was reflecting on that a little bit recently. It was back in, I think, we may have been the first to implement an energy harvester powered IoT cloud-based vibration sensor. That was in 2006. It was actually a part of a Navy contract, and it was actually, looking back on it, quite rudimentary. I mean, our files were going to like an FTP server that we were hosting, and the vibration analysis software was written in LabVIEW or MATLAB or something like that. But yeah, we've been in the space a long time. And our roots were really in energy harvesting, or that's, anyways, that was our path to the field of machine health and IoT.
Well, humble beginnings. That's amazing. I'm going to bring up a slide. Somebody at KCF released some collateral that I was looking over, and this will just give everybody a taste of where you guys are now. Can you see that?
Yeah, that's great. Yeah. It's been a long journey to get to where we are today, and our path, I feel, is maybe a little bit unusual, and that's even though it's unusual, it's kind of been the key to our success. We did not read a market report and pull in a bunch of investor money and then try and build something to address something that McKinsey thought that there was value in. We came from it a real grassroots kind of path where the original founders of the company were really working in really the machine behavior space with a focus on acoustics and vibration. So we were, solving problems from the very beginning with machines, and the focus was not on developing a technology to solve the problem. We were just pure, there's an acoustic problem with this asset. How can we change the mechanics of the operation or the design of that asset to address that problem?
Interesting.
It really kind of changes your mindset. It's a very sort of problem solving centric, which is oftentimes a little bit different than a technology focused perspective.
Yeah, that's interesting. So in my focus from
coming from corporate life where I had access to the OEMs and the machine makers. That's interesting to me. Were you, with that Navy contract, were you engaged with particular assets where you were addressing or trying to address behavioral issues on the asset itself? Is that essentially how that came about?
Yeah, I mean, that's interesting. I mean, actually, I mean, in that particular example that I was giving, we we were contracted by the Navy to essentially power a sensor. So in that case, I mean, the whole objective of the overarching project was to diagnose the health of that asset.
Hmm.
Our part of it was primarily energy harvesting, and then the wireless sensing and the measurement of the health of the machine was kind of ancillary, I guess, to that particular project. So, I guess the where we entered the technology space was really on the energy harvesting front. And that was a interesting time as well. It's a it's a market that looked a lot like the market that we're in now, the IoT space. But there's tons of startups back in the mid 2000s, and they really just fell apart. The market fell apart, and it was battery technology essentially that pulled that market apart. It was just at the same time as all this development was going on in energy harvesting, the energy density of lithium batteries was plummeting, or dramatically
Interesting.
increasing.
Yeah.
The cost was plummeting. The reliability was going up by a factor of 10, so it's like that just, it's hard to compete with a $3 battery, it's yeah, that's extremely reliable. How do you compete with that on the energy harvesting front? It's interesting. I mean, there are companies now who are building energy harvesting into their sensors, which is a little bit puzzling to me. But nonetheless, there's
Yeah,
probably
that's just so.
there in edge cases.
Yeah, yeah, it is interesting. And I'll try to talk to. We'll try to get some of those people on this show, so to speak, to have that conversation as well. So
Good,
just to
good.
continue in that thread, it's probably jumping down into the weeds a little bit. As technologists, we like to do that rather than stay at that high level. Although the one comment on that slide, when you say 135,000 assets monitored at multiple sensors per asset, you guys have really, the growth is phenomenal, I would say, in terms of the number of sensors you have out there.
Yeah, that's right. I mean, we've just been in the market for a long while, and we've had a lot of success and a lot of growth in many of our customers.
Um, so just to jump into that, get back to that battery, since we're on that thread, and that's, I've been doing a lot of work lately for clients on battery life and measuring battery life of IoT. And since it's an issue, when I took a poll with the Mobius group a couple of years ago as to what were some of the headwinds to deployment of IoT, battery life didn't register very high, but that changed. And a couple of years ago, I started to get calls about, can you help us out with this? We've deployed a bunch of sensors and the battery life is just not measuring up. You guys have one of the most detailed, I'd say, and extensive battery life specs out there of all the IoT vendors. Continue to explore with me, if you would, what you experienced in the batteries, what you guys did in the sensors, and I know we've talked a little bit about it in the past, how you characterize things.
Yeah, sure, sure. I mean, that the interesting thing about energy harvesting is that you don't have a reserve to tap into, and so like your energy balance is extremely important to make that sensor have sustained operation.
Mhm.
And so it really drove us to characterize the the energy consumption very carefully, looking, really understanding quiescent power consumption, really understanding with high fidelity the the startup current of various components. And then looking at the full operation of that sensor and where that current is what that operational profile is, getting that map right, and then taking that and looking at what is a reasonable life for that battery, considering these different, at different current draws, you get different, essentially, damage to the battery,
Right.
and
Right.
and then you look at that mapped over different temperature ranges, and then there's a degradation in the battery over just the leakage, essentially, of the battery over time, and you can kind of map out this whole space for predicting where that battery life is going to go. And it is important, to your point. I mean, that's the customer's experience is, right. You put this sensor on a machine, and you typically don't go out there unless there's a problem with the sensor. And the problems with the sensor are one of two things: you lose wireless connection or the battery dies. And every time you're going out there for that, for one of those reasons, it's it colors your perspective on the system, because you don't want to do maintenance on a system that's helping you prevent or optimize your maintenance.
Maintenance. Yeah.
Obviously.
Little contradiction in terms there. What has been your experience in the reaction from customers in terms of that total cost of ownership? If you're reducing those, service calls for the system itself, um, can you guys measure that, or have you gotten feedback from the customers? And how is that structured? Is that part of the service, that if it needs something like that, you guys are going to go and do it, or does the service or facility maintenance people have to do it? Or
Yeah, I mean, our business model is quite flexible. We do kind of both, offer both options. Many customers have the capability to do it themselves, some don't, and we just support them in the best way that we can. I would say, just from a practical standpoint, whether it's us or the customer, this problem needs to be addressed in two ways. Number one is the battery life has to be as long as you can absolutely make it, and that just has to do with designing a good product. And the second thing is that there are going to be cases like high temperature, for example, where batteries last quite as long.
yeah.
Or in some cases, we offer the ability to measure very, very frequently, measure an equipment very, very frequently. And some customers just want to do that. They're sampling once a minute perpetually, and that the batteries just don't last quite as long when you're in that operating mode, but they're fine with it. So in those scenarios, okay, make the batteries last as long as, or the batteries last as long as possible, or you make it as easy, you make that maintenance event very easy to handle. And there's a software component to that, to understanding where you're at and when to do it, when to go out and service the sensor, and then making it as quick and easy to service that sensor as possible. And that's something that, is unique about our sensors and customers appreciate.
Okay. That leads me to bring up. I'd like to bring up another slide, part of your collateral. So this is the latest generation sensor. I just put a couple bullets up from the online collateral, and you mentioned the high sample rate. So I hear this debated. We talk about it out in the industry. You've got applications and customers that need that extremely high or low measurement interval, a high frequency of measurement. What does that look like? It has to really tax the battery. And what's your battery life look like then? And what kind of applications? Can you tell us more, without betraying any confidentiality, about what kind of applications, are demanding that kind of sample rate?
Yeah. So, I mean, so I guess if you were to look at just kind of off the shelf technology, putting like a Bluetooth radio together with, a conventional, um, battery management solution and, using the standard profiles with Bluetooth, you're just not going to get, you couldn't possibly do this, what we're doing with our customers and what you're showing here.
Hmm.
It's just the system, the design decisions that went into that technology is different than what is seen in the industrial space. Like when Bluetooth was designed, they were making trade-offs to optimize essentially around point-to-point communication that's symmetric, bidirectional, basically, right?
Hmm.
In an industrial setting, it's radically different. In many cases where we have sensors deployed, there's thousands of sensors all communicating unidirectionally to a series of gateways, and that data from time point to time point all looks quite similar, right?
Hmm.
Machines don't change all that fast, and there's ways, if you understand exactly what's going on with that communication, you can optimize it to provide a much better performance in terms of energy consumption and much easier kind of deployment. So they can, there's no on button. They connect immediately to a wireless gateway. You can have hundreds of these connected to an individual gateway. All those are things that, through optimization of the communication, you're able to achieve these. And so, I mean, this is kind of an extreme case that what you're showing here. I mean, I think that the average, sensors to gateway is, I don't know, 30 to 100, somewhere in that range. And most of our customers measure machines on like once every, 5 to 10 minutes. However, I would say there are a bunch of cases where you do, for a period of time, want to measure much, much more frequently.
Hmm.
And in the case of like fracking, which is an industry, we're a Pennsylvania-based company, and we grew up just at the same time as fracking was coming online, and that industry demands, there are process changes that are happening and machine failure events that are happening with sub-minute resolution. And so we do measure those assets very frequently, and we're a part of a control system. So we're not just measuring the health. It could quite possibly be the most advanced implementation of using machine health in using it as an integrated part of process operations.
Hmm.
So in the case of the frac pad, we're measuring the assets very frequently. We're recommending to take assets offline when they're in a failure state, which is happening all the time, by the way.
Mm.
Rebalancing the fleet, recommending changes in the speed and gearing of individual assets to balance out the flow, to essentially meet a demand with the optimal machine health. So, it's
Wow.
quite complicated, but
Sure.
it's made a tremendous impact on that particular industry, and it just kind of shows where you can go, if you really use machine health to the fullest.
Wow. Yeah, that's really interesting. So it's not as simple as just let's just check it, make sure this thing isn't going downhill. You are part of the control system in a way. So is it operating at this frequency all the time, this measurement interval all the time, or
That's
is it
right.
triggered?
Yeah.
It is.
Oh no, well, yeah. You can't really trigger in this scenario because you've already missed the event, and and
Mhm.
you kind of, it all has to be operating in real time because these assets need to be pulled offline very
Mhm.
quickly because of the rate of the failure modes, and the algorithms are running in real time to basically, you know, derate some of the assets as when they're in a failure mode to preserve their life and to avoid secondary damage. So it's, you know, it's like a fully optimized kind of machine health solution.
Mm. Yeah, I suppose that's what you get when you're focused on an industry like that. You guys have developed some real domain expertise there, and there's certainly I can imagine a stickiness of the solution for that application.
Well, it's a particular kind of industry too. You know, it's you know, you got these, it's extremely capital intensive, and each one of these fleets or sites is exactly the same, you know. So you can make an implementation that can scale very easily across a bunch of different sites.
So yeah, I'd like to explore a little bit more on the sensor details, and this is the third generation. You know, again, get into the details. At least for me, a electronics guy and a sensor developer, find of interest, and then I'd like to explore the portfolio growth in terms of the application. So I'll just show the next slide I have up before that, and this is a slide that I show often publicly just to show the positioning. As everyone knows now today, there's just been an explosion in the last 10 to 15 years of IoT solutions for condition monitoring. And I'm doing my best to track them all. It could be a full-time job if I let it, but I also track the underlying technologies. And so this is a plot of the MEMS accelerometers that I find embedded in IoT solutions or that could be used in IoT solutions. And it's a performance plot. So I'm plotting noise and bandwidth and the full scale, the ability to, you know, measure vibration without saturating. And you can see there's a large variation in the kind of devices used out there. And you guys, I know, have made your choices over the years and continue to explore that. Can you comment on, you know, this is an essential technology. It's the you know, the embedded sensor essential to the function. Any comments about the choices you guys have made over the years and where you might be going with that?
Yeah, sure. I mean, this is a great chart, by the way, and just I appreciate your not just your sort of depth of understanding in this and characterizing where the market is, you know, when I look at this, the thing that comes to mind is that where you probably are kind of like what's the kind of optimal in terms of the cost benefit ratio of a technology. It really depends on the particular asset class that you're monitoring.
Yeah, is there an optimal position in this space, right?
Yeah,
This is
yeah.
what you
It's
want
a
to
little
do.
bit of a moving target as the technology moves and people's understanding and the AI improves and like so. I mean,
Right.
I would say, you know, the middle part is of this chart is pretty squarely on for the balance of plant, I think, you know. However, um, you know, there are a lot of assets that do require much higher fidelity, and there is a benefit to earlier detection, and that comes with you know, no lower noise floor and higher bandwidth. That's kind of the, you know, as I look at this chart, that's the benefits of moving to the right and the right lower order.
Yeah, and where your options are fewer, unfortunately, but yeah,
Yeah,
you can
exactly.
get there. You can get
And towards kind of towards the left of the chart, you know, those there's just no reason to be in that space when there's you can do it for the same price essentially to be in the middle
there.
if you use the technology well.
Interesting.
But
Interesting.
as you know, I mean, this is kind of an expertise area of yours as well, or your group is. It's not just the technology or the sensor that you put into it. That's one piece of it, but it's how you implement that as a part of the overall sensor system. That's so important. You can take the best accelerometer in the world and implement it poorly, and you end up on the left side here. um, and so, yeah, there's more to it than just the specs on a data sheet.
Yeah, that's a good point. I took that slide out. I have a slide of work we did for a new entrant into the space that were having trouble with the frequency response of their sensor, and it turned out, it just wasn't very well. The mechanics of it weren't well executed, and so they were having resonances. What should have been in band for the linear range were, they were having mechanical resonances induced into that, and that was a problem that the mechanics needed to be redesigned. So it's a good point. If you are going to extend the frequencies out into this middle range, there does need some care needs to be taken to the mechanical design of this. And you guys, I present at
Yeah.
this point in time, you guys have got the expertise, I would think, to deal
Oh
with
yeah.
that.
I mean, that was the start of the company. We were working on compressors and looking at the operational deflected mode shape and looking at how you quiet those down. And so, yeah, I mean, looking at the industry as a whole, the most mature, like the Wilcoxons and the PCBs, they design these little tiny accelerometers that have a
Mhm.
perfect bandwidth response or perfect frequency response, and then look at these clunky big IoT sensors, and I look at them and I'm thinking, there's no way that you're getting the same performance. It's very deliberate what PCB and Wilcoxon have done over the years. It's their 50-year history of lessons learned. And so it's yeah, the size of the sensor absolutely matters in terms of performance. How it's mounted to the equipment absolutely matters. The alignment of the center of mass with respect to the mounting hardware, all that stuff is so important. I mean, transverse vibration, some of these sensors are mounted, with this tiny little neck and then a big mass hanging up over the equipment. And it's triaxial vibration is not going to be measured very well in a scenario like that.
That's a good question. I mean, that's a little bit of a theological question. I've discussed it with various people over the years, triaxial versus just a radial axis measurement. Having three sensors, traditionally, having three sensors mounted on different spots on the machine to view different things. What's your opinion on the positioning of a triaxial? Let's say it's done well. If it's done well, placement and information gleaned from triaxial sensors versus several single axis, radial measurements.
Yeah, I mean, I think there's kind of yeah, that's a complicated one that we've struggled with over the years. If we've talked to so many experienced vibration analysts who uh y- like they're not going to use our sensor to do a diagnosis that's going to inform a $50,000 maintenance action, right?
Right.
They're going to go out there and do a high fidelity reading. So when you look at the workflow, what is really needed out of the sensor, you need a good baseline for knowing whether a significant analysis action needs to be taken and what is the quality and accuracy and level of information that you need for that. And generally that puts you in the middle region of your chart and with one or two axes, to be honest. I mean, I'm not saying that there aren't cases where a third axis is useful, but that's generally our position on it is that, this vision of just absolute understanding of what the fault mode is and going straight to a work order that gets executed. You know, I'm probably speaking to the choir because this is a Mobius, this is a Mobius
Yeah.
podcast. Like that, there's only a few scenarios where that probably is going to play out, and it's primarily where you're doing reactive maintenance anyways, and so,
Mm.
the real value is probably coming in where you of these systems is really coming in where you do need to do a second step, which is a more detailed analysis. And sometimes the online system can do quite well for that too, and you don't need to do all that much at the piece of equipment.
I've often asked people, when the flag is raised, the hand is raised, says, "Come look at me more closely." In most scenarios, is an operations manager really going to take the word of a red indicator on his dashboard to shut down the operation, shut down the machine? Or does he want to look, a maintenance manager in the eye and say, "Do we really have to shut this down, or can we run it? What's really the story? Can we run it for another, whatever, 30 days or 2 weeks?" Or
Yeah, I mean, there's guarantees by some of the systems. There's accuracy reported in the 90% range, and like all this sort of things, and including us. I mean, we in many scenarios we are achieving a 90% accuracy, but you know what do you do? Are you going to, that 10% of the time that it's not accurate, what do you do in those scenarios? I think is really what informs the overall workflow for how to handle these alarms.
right. Like to touch now on the expansion of your technology. I'm going to share another slide here. I actually put up something like this at Reliable Plant a few weeks ago in Orlando, and we were Reliable Plant's all about oil analysis, and Jim Fitch had asked me to talk about that. And you guys have come out with products that start to get at that, as have others. How do we include other measurands in the dashboard, in any kind of machine learning process we're going to implement? We want some more information to get at some of the other elements on the P to F curve. Can you talk about, the evolution of this product concept and what you guys saw driving this, and any insights into, the development and where you think this is going? We are trying to talk a little bit about the future here. So, um,
Yeah, absolutely. I mean, kind of a one unique kind of perspective that we've had, or like if you look at our sensor deployments versus many of the other IoT deployments out there, ours are big. Like ours per plant, our deployments are big, and it's because our customers that we do have, we've gone really all in with them. And when you do that, they want they don't see you as just like a gadget over here. You're fully integrated within their operations and their maintenance practices. And when you're at that stage, what they would like, they don't want like several different sensor systems. They want the most cohesive integrated solution that they can have. They don't want to integrate several different solutions into Maximo or SAP. They don't want to do separate integrations into their historian.
mhm.
So they only want a single software interface. And so I think the two blind spots that we've observed are, one is on complex assets. So you take like a gantry crane or a robot or a lift in automotive, or I mean, there's dozens of these more complex assets where you can't really wirelessly trigger well. You can't really, um, you can't really capture the samples at exactly the right time
Mm.
to characterize the health of that asset. So that's one region where we've gone. We've developed a solution to address those types of assets. And then the second piece is just the larger vision for sort of asset reliability. So that's like oil. There's legacy piezoelectric accelerometers out there on equipment. There's pressure transducers that make a big difference in how well you can diagnose machine problems. And we've tried to integrate as many of those into one sensor system as we possibly could, leveraging the same gateway infrastructure, same software, same connectors.
That makes perfect sense, and that's interesting. So, the hub here that you have with the various IEP interfaces, that's to service all, previously installed sensors. Apparently, you're not necessarily, or are you deploying legacy sensors for some reason, for some diagnostic reason to get the frequency response or
Yeah, it's a little bit of both. So, with a piezoelectric accelerometer, you can get a much higher bandwidth. So this unit does sample at a much higher frequency than our legacy or our standard wireless vibration sensors. And you can also, there's EMI challenges in certain environments, and there's also high temperature considerations where certain piezoelectric accelerometers are well designed for. So there's some new, but there's also some kind of legacy sensors that are already out there that we're pulling into this broader ecosystem of data.
Mhm. I talked to Des Case a little bit about your application. Can you tell us a little bit more about the evolution of that engagement and, the level of service and maybe where that's going in terms of, hooking up oil, some of these standard oil sensors out there and adding that to the suite of measurands and information that you have access to for analysis?
Yeah, I mean, the maturation of the market that we see is one where things, companies are much more open and collaborative, and particularly in the reliability space. And so we're happy to work with Case, and we're essentially integrating their sensor into our IoT ecosystem. And it's a good sensor. We've tested a lot of sensors out there on the market. And another value that they bring is that they can do services. Uh, they understand oil. That's their whole business, and
Mhm.
so that's a sort of a complementary capability to what we offer.
How is that integrated with your system in terms of the diagnostics or, the feedback you offer to the workflow or to any of the workflow systems? Is this Des Case that stoplight chart is from their collateral, I think.
Yeah.
Um,
Yeah, so this
that's
this sensor measures oil condition and humidity and brings that in, and then we essentially are plotting that right alongside vibration, and that helps you understand what's going on with. You'll see, like when you get water in the oil, you'll see your vibration typically go up, and you might not know why that vibration went up until you see the humidity level go up. Then you know the root cause, and it's much easier to solve. You aren't going out there replacing the bearing. You're just, uh, replacing your desiccant.
relubricating. Yeah,
Yeah, yeah, or whatever. Finding the leak, a seal leak, or something like that.
right, right. That's interesting. And so, and is their diagnostic information also included on your smart diagnostics dashboard? And
Yeah, that's right. Yep.
It's not a separate, server. You don't have to call Des Case to
No.
get the information. You
Yeah,
guys
it's
have
all
already
it's all
provided it.
integrated. Yeah, that's right. Yeah.
Okay, interesting. Where do you think the future of that lies? Are there future sensors? I mean, there are other aspects of oil health, right? The acidity and viscosity and all these other things. Do you see
Yeah.
some further work in this area with this case or with other oil experts?
Well, I think the one area that we just released a product is MCSA and ESA. That's something that I see out there. We go, yeah, there's uh, a bit on that. It's that just broadens the sort of fault modes and coverage of assets like big motors in particular. And there's a few other things that we're working on. I can't really disclose what those are, but yes, I definitely see there's some really advanced capabilities to diagnose certain types of um, precursors to failure, essentially. In most cases with vibration, you're measuring after the problem, when if you see a BPFO, your bearing is already on a path to failure. Yeah, can we catch it before you see that? Is really, can we I mean, oil is a little bit along those lines. Same with MCSA, but there's a couple other things that we're looking at.
Interesting. Yeah, I just I had noticed that you were getting into the motor current. How is that information? Because that's back at the cabinet, right? The electrical supply cabinet for the motor and the control system. How is that integrated with the rest of the smart diagnostic system, or is it?
Yes, exactly. Yeah. So we have the on the previous slide you showed this hub product, which is an 8-channel
Mhm,
wireless data recorder that
mhm,
can also be battery powered. That
mhm,
unit, essentially we have CT probes that plug into that, and then we take those measurements and pipe it back up to our cloud. So it uses the same wireless backbone. There's also a trigger in there for inrush to detect inrush current, which is super important for
mhm.
MCSA.
That's pretty exciting stuff. That's really seems to be, um, this vision for extracting more data, expanding the fault coverage. And that seems like it leads me to the sort of the next question. Let me see if it's the next slide. I'll get back to that. This is a quote I've used publicly as well. We'll get into the topic of AI because we've got a few minutes left now. You talk about machine learning in your services and implementing, state of the art machine learning into automating your detection and diagnostics. And this is, one of those questions. We can automate this to your point, but then, you want the confidence of that experienced subject matter expert. And, I've dealt with this in my own corporate life. Management, has this vision of what it can do. The algorithms are like magic, pixie dust that you sprinkle on all the data and great things come out. And as you just pointed out, there's a lot of elements to the P to F curve and a lot of aspects of real predictive maintenance program. Most of the data is still collected manually in one way or the other and sort of analyzed manually by the subject matter expert. But
Yeah.
as what's paint a picture for us of the vision now as you start to implement and integrate more and more measurands into the same platform. Um, is this where machine learning and classifiers, and I don't care for the term AI, but for lack of a better term, we got to use it because that's what everybody thinks it is. But there's a lot under that umbrella. But paint a picture for us of where you guys think that's going, and are you leading the charge? Are you kind of out in front in terms of implementing, you know,
Yeah, well,
data-driven approaches on more and more data.
yeah, I mean, I think yeah, so AI is, the whole field is quite interesting. I mean, there's a lot going on. We're doing a lot, and I think there's a lot of promise in it, a lot of value that can be derived from it. I think before we just, any company just jumps in, I think the key thing that needs to be asked is why. Like what is the value proposition around AI? Why are we doing this?
Mhm.
Because it's not an ultimate good, right? It's not, there's, I think that in the machine health space in particular, some of those answers are that can we make the life of maintenance and reliability engineers more productive, more efficient? Can they be uh, going into the office at three o'clock in the morning less often? Can they stay at home with their kids on the weekends and not be expected to be, coming in, you know, uh,
Yeah.
and then for leadership, can I fill the roles in my plant as with the aging workforce that I have? Can I retain the talent that I do have? Those are the questions that AI really needs to help us with, and less so on the like, okay, I don't know how to interpret this vibration signal, or like I don't know what the fault mode is. AI, please tell me what that is. Right? That's not I. Just maybe it's just my perspective, but I just don't believe that that's where we're at. I mean, this is not like a chat bot, like that
Mhm.
is
Yeah.
producing something that you can just look up on the internet. There's been a 50-year history of vibration analysis and machine health monitoring that's gone into the very nuanced sort of understanding of how the mechanics of a failure of assets.
Mhm.
For AI, yes, AI is going to be able to essentially replicate what a human does, but the value here is just in improving efficiency, essentially. That's where I see this going, and essentially elevating the skill level of people.
Right. So yeah, that's right. That touches on, and you're hitting all the points that this kind of audience wants to hear. And I share your opinions. We both work with people like David Siegel and others who are experts in this space, and we just don't see it replacing the subject matter expert anytime soon. But to your point about the aging workforce and somehow capturing some of that domain expertise, that 50-year history, as AI play a role in some of that to aid the younger workers that we're training every year at Mobius and Vibration Institute and others, technical associates. Those people coming into the workforce, which we value, which are valuable, we desperately need them. Does this is this an aid as well to some of those less experienced? I know that's a tough question, but
Yeah, no, definitely, and to get to the same, it's kind of like to get to the performance of a 20-year veteran, Cat 3 vibration analyst. The AI is going to take a long time. We're talking like you have to have thousands of training data sets for every fault mode on every different type of asset. I mean, that means that we need sensors deployed on every single asset in industry for a substantial period of time, basically, and
Mhm.
have all that data in one place, developing
Right.
the one cohesive set of algorithms that everybody is using. I don't know. It's going to be a while, but can you get a level one vibration analyst up the curve quicker? Yes, I did. You definitely can do that. Or can you take a maintenance engineer who's like interested in reliability, but has no formal training, can you get them interested enough and understanding a bit more about what the health of the assets is, and then uprate their skills, and maybe they start taking some courses and learn more about vibration analysis.
That's a great, excuse me, that's a great point. I mean, experience is experience. Experience is essentially, implementing inference with human intelligence on gobs and gobs of data that you've observed and collected over your lifetime, right?
Right.
So you can't replace that. There's no algorithm that can replace that treasure trove of information, even if it can start to approach with enough information, making the inferences that every 5-year-old will make on, certain observations in life.
Right. Yeah. Yeah. I mean, I think control, there's other areas outside of, reliability is kind of like, it's not a real time thing usually, but once you get into the control space where you need to be processing stuff extremely fast, that's, of course, AI is going to play a huge role in that.
Yeah, oh, sure, because it is a machine. So the efficiency and the latency and the processing prowess of a machine can replace that. A couple of weeks ago I went to the battery show up in Michigan with an old friend of mine. He's a applied math PhD, and he does optimization for a trucking company. And there's a lot of robotics there. There's a lot of manufacturing there. Watching it is fascinating. Watching a machine work with precision, rapidly, it's mesmerizing. It's mesmerizing. But, we were watching them do some fairly simple tasks, move one part from one place to another place. Yeah, they can do that all day long,
Yeah,
with precision. No human wants to do that, right? So,
exactly.
well, this has been a great conversation. Any further prognostics, words of wisdom from your own point of view? We've got a few minutes left in the session. Jacob, I just want to take the opportunity now to really thank you for your time. This has been a fascinating conversation. I always enjoy talking to you. Any
Likewise.
sendaways
Yeah.
for the Mobius audience that will see this?
I mean, what we've mainly been talking about today is tools to put in the hands of someone whose, maintenance is largely going to be unautomated for years to come. And, we're largely talking about a tool to enable an action, and the action piece is so important. So in some sense, I feel like we've been talking about 20% of the problem, the bigger problem, which is just like, can we do the right labor at the right time? And a lot of that, there's a lot of other factors that go into that other than just a diagnosis from a tool. And we're trying to work on that end of it too, of, like, how can we create a dialogue to keep track of issues, and how can we promote the visibility of issues, and how can we help decision making around where to spend time. And those are things that are a little bit more the softer side of reliability, but are so important. That you can have all the best AI in the world, all the best sensor fidelity, but ultimately, if you can um, spend your resources on the right things in your plant, you can make a much bigger impact than any sort of, doubling of bandwidth of the sensor.
Mm,
That's something that
yeah.
we're very cognizant of, and I hope we can help the field along in that arena as well.
So one last question. This is a tough one, and I have to squint and look into the future. But from your vantage point, will it be when I go to the conference, a lot of the AI oriented or software platforms out there are operating at that sort of operational OT or even enterprise level. pulling all the data together and helping big decision makers for the operations manager, or even the business managers. Where will the big contributors come from, in your view? Will it come from guys like you, or will it come from the Maximo and SAP and some of these other outfits that are trying to apply these tools, these data-driven tools, to all the data coming in?
Oh boy, that is such a complex space, Ed. I wish I knew the answer. I mean, we are with all the different customers. We're in lots of different industries, working with lots of different sizes of companies, and it's different all across the board. And I just don't. It's going to be a diversity of different implementations is the easiest thing I could say, I think. I think you're still muted there, Ed.
Yeah, you're right. I'm sorry. That's to tee you up. You had 3 whole minutes left, or 2 now. That's a big conversation, and one suspects, as you just said, that it'll come out in specific applications, where the knowledge is, where the domain knowledge is developing, and where the tools are in place. That's where you'll see the most progress in that space, I suppose.
Yeah, and I mean, I think the best thing that we all can do, every player in this space, is just be open with your data, open with your workflows, open to collaboration with different software systems, different parts of operations and reliability, bringing those together. I mean, that's what has to happen. Operating in silos is just something that's going to die. I mean, it's just, it won't be that way in the future. And so we got to really collaborate, I think.
It's a great word to end on. Jaclob, thanks again for your time. Great conversation. Maybe we'll pick up some of these other topics in a future conversation. We'll see how this series plays out, and how the ecosystem at Mobius responds to it. So I just want to thank you again. Kim, thanks for hosting, and we'll close it out. We'll let you know about the next one coming up as soon as the details are available. Take
Wonderful.
care.
Thank you, Ed. Thank you, Mobius.
Ed, thank you.